7. Solving quadratic inequalities. Many business profits can be modeled by quadratic functions. To ensure profit is above a certain level, financial planners may use or need to graph and solve quadratic inequalities. A quadratic inequality can be written like any quadratic, except for now we're going to have the inequality symbols. I have y is less than ax squared plus bx plus c. Y is greater than the basic standard form. Y is less than or equal to standard form. Y is greater than or equal to standard form. Those are your 4 different inequalities. When we graph quadratic inequalities, we graph the parabola that defines the boundary. So we graph as we usually do. We use a solid parabola for y is less than or equal to, and y is greater than or equal to. It is a dashed or dotted line when y is greater than or is less than. For the shading, if it's any of the greater thans, it's shaded above the line. If it's any of the less thans, it's shaded below the line. First thing we're going to do is by hand we're going to graph y is greater than or equal to x squared minus 7x plus 10. Whenever we're graphing, what does every parabola have? A vertex. Now I'm going to show you a quick way to find the vertex. First we're going to find the AOS. To find the AOS, it's negative b over 2a. Negative b over 2a should sound very familiar now. Where did we see that at? The quadratic formula. It was the beginning part of it, right? That beginning part is your AOS. So what's your b? So I have negative 7 over 2 times, what's your a? 1. Negative 7, positive 7. 2 times 1 is 2. So I know for my vertex, I have 7 halves. So you know that's 3.5. What do I do to find that extra point in the vertex? Anyone remember? What's that? Put it into the equation. I'm just going to take and store it in. I'm going to take 7 halves. I'm going to store it in for x. Press enter. So everywhere I type x, it thinks 3.5. X squared minus 7x plus 10. Negative 2.25. Just to be consistent, I'll put negative 9/4, even though I know that's negative 2.25. So I'm going to graph that. Negative 2, or sorry, 1, 2, 3.5, 1, 2 1/4. Your vertex is right there. Knowing things about your parabola is also going to help. Does my parabola open upwards or downwards? Why is it upwards? What is positive? If the A is positive, it's going to open up. If it opens up, it hits here 2 spots, right? So I got to see if I can find the zeros. Can I find the zeros easily? Can I factor that? 2 numbers that multiply to get me 10, but added together get me 7. 5 and 2. X minus 5, x minus 2. Which means I have zeros at 5 and 2. I have zeros at 2, 3, 4, 5. 2 and 5. Now I have 3 points. With this, I can make the U. Questions up to now? Oh, sorry, I have one problem. I shouldn't have did this. Reason why, I need to look here. Is it a solid or dotted line? Solid line. Why? Has that equal to? So it is a solid line going through. The negative 9/4, I substitute in 7/2 in for x. And that tells me my second point. Now, greater than or less than, that's what I need to look at. When it's greater than, you shade above the line. So I'm going to shade above the line. If it's less than, you shade below the line. You notice that I'm saying above and below. I know the shading goes inside. But what happens, let me move that so I can grab that. If the graph was like this, where is greater than? It's above it. So actually above the line is all of this stuff. I can't say greater than is going to shade inside. But I can say if it's greater than, it shades above the line. Let's go back to what we had. What this shaded region means right here, anything in there is a solution. If I was a business, what that is telling me is where's my profits? I'd have to sell it for something in that price range to make money. Anything on the outside, I'm going to lose money. Let's look at this one. Y is less than negative 3x squared minus 6x minus 7. There's numerous ways I can go and find all the pieces for this. I could go and find the zeros by factoring, quadratic formula, completing the square. I could go and find the vertex by changing it into vertex form, which we said sort of like completing the square. I'm trying to show you what's one of the easiest ways to graph by hand. Find the AOS, which is negative b over 2a. What is your b? Negative 6. Don't forget to take the sign. 2 times, what's a? Negative 3. Negative negative 6 means 6. 2 times negative 3, negative 6. X is negative 1. So I know my vertex is negative 1 comma something. How do I find that something? Substitute in that negative 1 in for the x's, right? I really don't need a calculator for this. It's easy to work with the number 1. What's negative? I have negative 3 times x squared. So what's negative 1 squared? 1. What's 1 times negative 3? Negative 3. What's negative 6 times negative 1? Positive 6. And then I have minus 7. All right, I'll put my negatives together. What's negative 3 and a negative 7? Negative 10. What's negative 10 and the positive 6? Negative 4. Sometimes it's easier for you to put your negatives together, put your positives together, and then combine them at last. So at negative 1, negative 1, 2, 3, 4. Now I'm going to think for a second. Does my parabola open upwards or open downwards? Why downwards? Negative a. So if it opens downwards, do I have any zeros? No. What would happen if I would use the quadratic formula? You have plus or minus, what's going to show up? When do you get non-real answers? When you have the square root of a negative number, when your eyes show up. So finding the zeros isn't going to help. Factoring helps you find zeros. So any method that helps you find zeros is not going to help me. So I can just pick a point. Now, we want to pick a number that's going to be easy to deal with. I'm just going to pick the number 2. You can pick whatever number you want. I would not pick the same vertex. So you want to pick any number you want. Now the problem is, the bigger the number, the further away it's going to be, and more likely your number is going to be too large. You want to keep it fairly close, within 1, 2 away. All right. I'm going to take this 2, store it, and for x. All right, I'm just going to, I'll just retype it. Negative 3 x squared minus 6x minus 7. I could also keep hitting second enter, second enter, second enter until it shows back up on your screen. Your answer is negative 31. Can I graph negative 31 right now? No. Sometimes this happens. I don't expect you to erase your entire graph and start over. When this does happen, all right, 2, negative 31 is off of my graph. I just label it. It's off your graph. It's 2, negative 31. I'm not expecting you to change your entire graph and start over because you get that point. What do we know about parabolas? What happens through the vertex or through the AOS? What do I know about the AOS in a parabola? Whoops. If I draw the AOS here, what does it do to my parabola? Splits it in half. So I have points that are symmetrical from one another. If you look, this one's 1 and a little bit, this one's 1 and a little bit. So if I looked at this point here, it's 1, 2 away, correct? Or sorry, 3 away. Can't count today. 1, 2, 3. I'm going to go the other way, 1, 2, 3, and then it's down here. Because it has to be symmetrical. Is my U going to be dotted or solid? Dotted. So I'm just going to draw a dotted U. My shading, does it go above the line or below the line? Less than is below it, so below the line is down here. From Algebra 1, when we're talking about inequalities, if you have something that's an and statement, both of the conditions must be true. So x has to be greater than 3 but less than 5, or and less than 5. The number has to be in between 3 and 5. If it's an or statement, only one of them has to be true. I have x squared plus 8x plus 20 is greater than or equal to 5. We'll use the calculator to help us out. So turn on your calculators, press y equals x squared plus 8x plus 20. Put this one in y1, put the other one in y2. Put the one side in y1, second side in y2. Once we do that, let's hit zoom 6. That way everyone gets taken to the exact same screen. If you do zoom 6, it takes you to the same standard window. There's your graph. Greater than 5. So it means this is 5 right here. If it's greater than, everything in here is shaded. If it's greater than 5, everything above the line, that's 5, it gets shaded. If I hit second graph and look at a table, We care about when the numbers are greater than 5. Bigger than 5, bigger than 5, bigger than 5. Notice that I see 1 where it's not bigger than 5. Where is that at? At negative 4. If you see on your graph, at negative 4, it's 4, and 4 is not greater than 5. But then when I'm back to the negative 5, it's good. So what this is saying, in between negative 3 and 5 does not work. So I have x has to be greater than or equal to negative 3, or x has to be less than or equal to negative 5. It splits it in half. There's a table that is less than it, there's a table that's greater than it, and in the middle something doesn't work. If you think on a number line, here's negative 4, negative 5, negative 6, here's negative 3, negative 2. It doesn't work at negative 4. At negative 5, it does work. Negative 6, it does work. Negative 7, it keeps going on this way. At negative 3, it works. Negative 2, it works. Negative 1, and so on. Everything this way works. Or statements go opposite directions. When you look at a graph, an or statement is going to cut off the vertex. Same graph, or same equation, correct? What has changed? It's less than. So now if I look at this, the place where it's less than is that little piece. That is where it's less than 5. Just in that one little spot. Looking at our table again, the only one that works is negative 4. Everything else gets me numbers that are bigger than 5. So anything between negative 3 and negative 5 works. See the vertex is being connected here, and that's what's shaded. This is an and statement. X has to be less than or equal to negative 3, and x has to be greater than or equal to negative 5. If you remember from previous years, and statements can be written as a compound statement. You can put them together. I take this and flip it around. Negative 5 less than or equal to x. Took the entire problem and flipped it. I can take this and transpose it on there. So I really have negative 5 less than or equal to x less than or equal to negative 3. You can have what's in the red or what's in the black as an answer. That's using the graph and the charts to help me out. Ors are going to be shaded above, or not above, it's going to have the vertex cut out. The ands, you're going to only have the vertex part connected.